A small machine drifted away from its mothership and began falling toward a comet. For more than 10 years, the Rosetta mission had chased this icy world across the solar system. Now, after billions of miles of travel, everything narrowed to a single descent. Beneath the spacecraft, the comet rotated through darkness and sunlight, carrying mountains, cliffs, and dust fields through space at thousands of miles per hour. The lander was called Philae, and if everything worked, it would become the first spacecraft ever to land on a comet. As Philae separated from Rosetta, there was a sense that the hardest part was almost over. The comet had been found. The rendezvous had been completed. The descent had begun. All that remained was touchdown. Far below, the surface grew larger. The lander descended slowly through an environment unlike anything engineers routinely work with. The comet's gravity was so weak that a strong jump could have launched a person back into space. Philae was designed for that reality. The moment its feet touched the surface, harpoons would fire downward. An onboard thruster would push from above. The lander would pin itself to the comet before gravity had a chance to let it drift away. The entire sequence depended on those systems working together. Then the first contact arrived. Touchdown. History had been made. For a brief moment, it appeared the mission had succeeded exactly as planned. But the surface did not hold on. The harpoons never fired. The thruster failed. The landing gear absorbed the impact, but nothing secured the spacecraft to the ground. Instead of settling onto the comet, Philae rebounded. The first comet landing had just happened, and the spacecraft was already leaving. The bounce lasted far longer than anyone expected. In the comet's weak gravity, Philae rose back upward, drifting away from its intended landing site. Below it, the surface slowly rotated. Cliffs passed beneath. Shadows shifted across the terrain. The spacecraft remained alive. Signals continued reaching Earth. Instruments still responded. If the landing failure had destroyed the mission, those signals should have disappeared. They did not. The temporary explanation seemed obvious. The mission was in trouble because the landing hardware had malfunctioned. Yet the spacecraft kept working, and that made the situation stranger. The bounce was not the end of the story. It was the beginning of a new one. Eventually, after another contact with the surface and another movement across the comet, Philae came to rest somewhere. Mission controllers knew the spacecraft had stopped moving. What they did not immediately know was where it had stopped. The lander had become a lost object on a world barely mapped in detail. Recovery still seemed possible. After all, the spacecraft was communicating. Science instruments remained available. The mission had survived. Then the telemetry began arriving. Not images of danger. Not signs of catastrophic damage. Something quieter. The sunlight readings were wrong. Solar panels that were supposed to receive regular illumination were spending too much time in shadow. The numbers kept pointing toward the same conclusion. Philae was alive. But it was not where planners wanted it to be. The surface location mattered more than anyone had realized. Somewhere around the lander, terrain was blocking the sun. A cliff. A wall. A ridge. The exact shape was unclear. The consequence was not. The spacecraft was receiving only limited sunlight, and sunlight was supposed to become its future. The meaning of the crisis began to change. The failed harpoons had created the problem, but the shadow was turning it into a countdown. The image that eventually emerged was stark. Philae appeared wedged within rough terrain, surrounded by towering features that restricted sunlight for much of the comet's day. The lander was functional. Its instruments worked. Its communications system worked. Its environment was slowly killing it. Battery power had become the mission's most valuable resource.
The high-gain antenna
Every
rotates,
transmission
seeking a
consumed some of
connection
it.
home, as the drill
Every
mechanism
measurement
begins to
consumed
penetrate the
some of
comet's
it.
icy crust.
Every decision consumed some of it. And unlike many engineering problems, this one could not be negotiated with. No repair could create sunlight. No software update could move the cliff. The clock was already running. The mission entered a different phase. No longer exploration. Salvage. The question was no longer whether Philae had landed successfully. The question was, what could still be recovered before darkness won? Commands began flowing toward the comet. Instruments were activated. Measurements were collected. Data was transmitted home. Each success carried a cost. The spacecraft's remaining energy reserve became a shrinking inventory of opportunities. One more experiment meant less power later. One more transmission meant less flexibility tomorrow. Even routine actions carried unusual risks. The comet's gravity was so weak that mechanical movements inside the spacecraft could influence the spacecraft itself. Engineers had to think carefully about every operation. Options were disappearing faster than solutions appeared. Yet science continued. Philae examined the surface. It sampled the environment. It returned observations from a place no spacecraft had ever operated before. Hour by hour, valuable data crossed the enormous distance back to Earth. The battery level continued falling. The sunlight situation did not improve. The shadow remained exactly where it had always been. By now, the mission's objective had transformed completely. At the beginning of the descent, success meant arrival. Now success meant extraction. How much knowledge could be rescued before power vanished? How much value could be pulled from the remaining hours? The spacecraft kept working. The battery kept shrinking. The two curves moved toward each other. Eventually, the final phase arrived. The remaining power reserve was nearly exhausted. Commands became more selective. Transmissions became more important. Every remaining minute carried weight because there might not be another. Then, after roughly 60 hours of surface operations, the signal faded. The spacecraft entered silence. Not because it had crashed. Not because it had been destroyed. Not because the instruments had failed. The environment had simply run out the clock. Far from Earth, on a comet moving through deep space, the lander sat beneath shadowed terrain and stopped speaking. Yet by then, something important had already happened. The mission had recovered critical scientific observations. The data had arrived. The opportunity had been used. The countdown had reached its end, but not before the spacecraft delivered what it could. The story had begun with a landing. That is how history remembers it. A spacecraft reaches a comet. A spacecraft touches the surface. A spacecraft becomes the first of its kind. But the meaning changed the moment the feet touched down. Arrival was never the final challenge. Arrival revealed the final challenge. In the darkness beneath those towering comet cliffs, Philae became something different from a historic lander. It became a finite resource. A machine trapped in shadow, spending the last of its battery to rescue a mission. And that is why the bounce mattered more than the landing.
The first touchdown made history.
The hours that followed gave that history its meaning.